Today's lesson is chapter 12.1, and we're dealing with exponents. And what I'm going to teach you today is the product rule. We know that we have a raised to a certain power, and we say n. That means that we're going to have a times a times a, and we're going to have it n times, right? The product rule states that if it's a to the m power times a to the n power, you're going to simply add the exponents. For example, we have 3 to the 5th times 3 to the 7th. They have to be the same base. So in this case, we have the same base. So what you do with the exponents is that you add. So you have 3 raised to the 5 plus 7, which is 3 to the 12. What I'm going to do for example A, I'm going to use a product rule to simplify each expression. For number 1, we have 4 raised to the 2nd power times 4 raised to the 5th power. And since they have the same base, we have to add the 2 and the 5. So we have 4 raised to the 7th power. In example 2, we have x raised to the 2nd power, and we have x raised to the 5th power. Since we have the same base and we're multiplying, then it will be x to the 7th. We're going to add 2 plus 5. The next one, we have y to the 3rd. So we have y to the 3rd times, since we have y by itself, the exponent is going to be 1. So they have the same base, so we add the 3 and the 1, the exponents. So we have y is raised to the 3rd, is raised to the 4th power. For example 4, we have the base, which is -5, and both of them are raised to the 7th and 8th power. So it's going to be -5, parentheses, raised to the 7th, times, parentheses, -5 raised to the 8th. So we're going to have parentheses -5, and we're going to add the exponents. So we have -5 raised to the 15th power. For example B, we're going to use a product rule to simplify each expression, just like we did in example A. So what we're going to do is we're going to go first multiply the integers. So we have 2 times -3, which is a positive times a negative, gives you -6. And we have x to the 2nd times x to the 5th. So we're going to have -6, and since we have the same base, we're going to go ahead and add the exponents. So we have x raised to the 7th power. For the next one, we have 2 different bases. We have x to the 2nd times x to the 3rd. So I'm going to go ahead and do that first. X to the 2nd times x to the 3rd. And I also have y times y to the 2nd. So since we have the same base, it's going to be x, and we're going to add the 2 and the 3. So it's going to be 2 plus 3, which is 5. Y is raised to the 1st power. It's understood. So it's going to be y raised to the 3rd power. For number 7, we have negative a to the 7th power, a to the 7th power, b to the 4th power, times 3 times a times b to the 9th. So 3 times negative 1 is negative 3. And then we have a, and we have a 7, and it's understood as a 1, so it's going to be 8. And then we have b, we have a 4, and we have a 9, so that's going to be 13. So that's what it simplifies to. The next part of the lesson has to deal with the product rule, the power rule. So if we have something like 7 to the 2nd power, and that's raised to the 3rd power, then it's actually 7 to the 2nd power times 7 to the 2nd power times 7 to the 2nd power. Or you can just simply multiply 2 and 3, since you have 3 sets of 2. So it's 7 raised to the 6th power. Just like they have here, we have negative 5, and that's raised to the 3rd power. And it's raised to the 7th, so all you have to do is multiply. And you have negative 5 raised to the 21st power. So number 9 is a good example of this. We have 8, we have y raised to the 8th power times y raised to the 8th power. Or you have y raised to the 16th, and you notice 8 times 2. We have 9 raised to the 4th power raised to the 10th power. So this will be 9 raised to the 40th power. And then for number 11, we have z raised to the 6th power, and this is 18th power. We're going to talk about the power of a product rule, and a good example would be, let's say you have 3 We're going to talk about the power of a product rule. A good example would be 3x to the 5th power. You notice that we have 3 times x is raised to the 5th power, so we can also state the following: 3 to the 5th times x to the 5th. Okay, and you notice we kind of separated it. So if we look at 12, we have s times t, that's in parentheses. Raised to the 4th will be s to the 4th, t to the 4th. Number 13, we have 2 times a, and it's raised to the 3rd. So it will be 2 raised to the 3rd power times a raised to the 3rd. You notice that individually, they're also raised to the 3rd power. Now, we do got to be careful. If we do have exponents, that means that we're going to have to multiply. So if you look at the first one, we have negative 5 raised to the 2nd power. Now we have x squared raised to the 2nd power, so that's going to have to be x to the 4th. Because you have a power raised to a power, you're going to multiply. You have y, and we have 3 raised to the 2nd, which is going to be 6. And we have z, that is to the 2nd power. Now, when we do have a negative, we also have to be careful. Make sure you write your negative inside of parentheses and then raise it to the 5th power. And we will have y, and it's going to be raised to the 15th power because you have 3 raised to the 5th power, so you're going to have to multiply. You're going to have to find the product. The quotient rule refers to when two terms are being divided. So, for example, you have y divided by 7, and this is a quotient. It's raised to the 3rd power. Then what you can say is y to the 3rd divided by 7 to the 3rd will be its equivalence. So if we do 16, we have m divided by n, and that's raised to the 7th power. So we will have m raised to the 7th divided by n raised to the 7th. If we look at 18, we have r divided by s raised to the 6th power. That will be r raised to the 6th power divided by s to the 6th power. Now, as you notice with 17 and 19, they're a little bit more complicated because we have an x and a y, and we also have numbers. But it's still going to follow the same rule. So if we have 2x to the 4th divided by 3y to the 5th, and it's raised to the 4th power, then we can raise each of them individually to the 4th power. For example, 2 to the 4th times x, and we have 4 raised to the 4th power, so that's going to be 16. How did I get 16? You multiply 4 times 4. You will have 3 raised to the 4th power, and then you will have y raised to the 20th. How did I get 20th? You multiply 5 times 4. So for number 19, we have 5 times x to the 6th divided by 9 times y to the 3rd, and that's raised to the 2nd power. So now we can raise each of those terms to the 2nd power. So we have 5 to the 2nd power, and we have x to the 6th raised to the 2nd. So 6 times 2 is 12. Then we have 9 that's raised to the 2nd power. And we have y that's raised to the 6th. How did I get 6? 2 times 3. So basically what you're doing is you're multiplying the exponents when you're raising it to another exponent. So what happens if you're dividing two terms? Well, if you have something like this, you have x to the 6th divided by x to the 2nd, then we know that we will have to be subtracting the exponents. How do I know that? Because you have x times x times x. That's 3x's times x times x times x. That is 6. And then you have x times x. And you notice this is 1 and this is 1. So you're left with 1, 2, 3, 4. You're left with x to the 4th. So that's how they developed the rule. Since we are dividing, we will have to be subtracting the exponents. You notice x cannot be equal to 0, because if x is 0, then this will be undefined. Remember, it has to be the same base also. So if I have x to the 5th, I have x to the 5th divided by x to the 2nd. We have to subtract the exponents, 5 minus 2, so we have x to the 3rd power. For 21, we have the same base, so it will be 4. And we have 7 and 3, so we're going to subtract 7 minus 3, which is 4. So 4 to the 7th divided by 4 to the 3rd will give you 4 to the 4th. 23, we have parentheses negative 3 to the 5th, parentheses negative 3 to the 2nd. So we're going to have parentheses negative 3, and we have 5 and 2, so we're going to subtract, so it's going to be 3. 2 times x to the 5th, y to the 2nd, divided by x times y. Well, we notice that we have a 1 there, so it's going to be 2 divided by 1 is 2. We have an x to the 5th divided by x, and that's a 1. So it's understood as 1. So 5 minus 1 is 4, so we have x to the 4th. And if you see with the y, it's understood as 1. So y to the 2nd divided by 1 is by y is going to be y. 3 to the 0 power is going to be 1. Anything that is raised to 0 will be 1. So you see how this entire term here is 5, x to the 3rd, y to the 2nd, raised to the 0, that will be 1. So for the quotient rule, when you're dividing, you will be subtracting the exponents.